Hi everyone, it's Miss Salvatore here. I wanted to come on and see if I could be able to help go through some math vocab with you so that you can apply it with a lot of the word problems or some of the things that you're learning about in class. And hopefully you can reference this at any point because there are a lot of terms to know even in math. So I hope that this helps some of you. I'll go through some of the most important vocabulary words that you're working on right now that you can use to apply in your classwork and for any upcoming assignments. And then also at the end of the short slides that I did put together, I have a little challenge question. So feel free to interact with me a little bit and see if you can get the answer. All right, so let's go ahead and share our screen and we'll go over some basic, excuse me, math terms. All right. All right, awesome. So the first word we're going to talk about is increase. And if you know anything about the prefix in, it means to build or to get bigger. So thinking about that, increase, and then looking at this picture here, if we're going from blue to green to orange to red to green to dark blue, it increased. It means that the value of something has gotten bigger. Okay, the size or the quantity, everything has increased. The rate has increased. Okay, so it is getting bigger or the numbers are increasing. And an example of that would be the value of the dollar increase throughout the day. So there are a lot of different apps. I can pull one up real quick while we're sitting here that I sometimes check just so I can see it. And I do see a lot of increases and decreases when we're talking about currency and different trends around the world. So you would be able to use the word increase as you talk. And of course, my app is going to be slow right now, but when it does get pulled up, I'll be able to show you in live time things that increase throughout the day. Stock markets or things that are linked to stocks or cryptocurrency or something like that. You'll see an increase or decrease, and you'll see a lot of graphs that look like this. So that is the word increase, to make something bigger. The opposite of increase, and you'll see the prefix de, means to lower, to make something smaller in size or quantity. So this is just a graph of air concentration. You can see the different graphs, and you can see, for example, the blue is an urban area in the UK. You can see it started at 300 and it decreased, okay? So decreased means that we make something smaller. Now we want to talk about when we're charting or graphing things, and you have two ways that you can graph things. You have an x-axis and you have a y-axis, okay? So usually you are graphing points within the x and the y-axis or the axes. Okay, so let's talk about the x-axis. The x-axis is the line on a graph that runs horizontally. So if you're going from left to right, it runs horizontally. So you're thinking about the horizon when the sun comes up, that line, the sun rises over that line. So it's always from left to right, okay? It is used as a reference line so that you can measure. So right here, if you see my cursor, and I will annotate on this real quick just to make sure that you all can see it. Right here is your x-axis, okay? Your x-axis. Okay, we'll close that, okay. If you have your x-axis and it's going horizontally, let's think about the y-axis. And you can actually also see it in this picture. It is labeled. So the x-axis is horizontal. Now we talk about the y-axis. It goes up and down, okay? The y-axis goes up and down through 0. So you can even see on this chart here, we have the x-axis right here going horizontal, and then you have the y-axis going up and down. It is used as a reference line so you can measure from it. Again, maybe you're plotting some points, but you usually need to have something on the x-axis and the y-axis wherever they meet. So I'm sure you're doing some of those practice questions now. I'd be more than happy to arrange a small group or another PowerPoint to go over graphing and plotting your points on an X and Y axis. When we're talking about numbers, we have a lot of different numbers, a lot of different integers. We have a positive integer, positive number. That just means it is greater than 0. So 0 is our starting point. Anything to the right of our number line greater than 0 is a positive number. It is more than 0. The value is more than 0. Okay? The opposite of positive is negative, which we are going to talk about. And just looking at this and knowing that if we always start with 0 and positive is greater than 0, think in your head what negative might mean. So really quickly, an example is 5 is positive. 5 is a positive number. So as you can see on my number line, I'm sorry, it cut off a little bit, but you would still have after 3 comes, whoops. After 3 comes 4. And after 4 comes 5. 5 is a positive number. And sometimes you may see it written with a plus sign in front of it so that you are showing when you're working with both positive and negative numbers that number is positive. It's a positive 5. And then you can go about your equation with it. So look for those signs in front of some of your numbers. And now we move on to negative. Okay, negative is less than 0. So if we're looking at that number line with the starting number being 0, 0 is our starting point. Anything to the left of that number line is less than 0, right? So 0 is not negative or positive, but anything to the left of that number line is less than the value of 0. A negative number is written with a minus sign in front of it. So as you can see on here, if we're looking at the starting point of 0 in blue, okay, and you'll start to see it's not 1, 2, 3. It's -1, -2, -3, -4, and so on and so on. Okay, and then again, just an example, if you see that negative sign in front of a number, that means it is negative. So this says -5. All right, let's talk about initial value or the starting point. Okay, the initial value is the beginning output value or the Y value when X is 0. The rate of change is how fast that how fast the output changes relative to the input on a graph. So if we're looking at a graph, this is kind of a good place if you are starting at, let's say, on an X and Y axis at 0, 0. And whatever you're measuring, maybe it goes up to 1, 4. Your initial value, you're always starting at 0, 0, usually 0 for the X and 0 for the Y axis. And that is your initial value, where you start, your beginning value, okay? And then the rate of changes, you'll start to see it go up positively or come down negatively, and you would be able to graph all of those changes. So initial value and starting point, where you're starting, which is your beginning output value. Okay, next one, ratio. A ratio shows the relative sizes of 2 or more values. So it can be shown a few different ways. We can use a colon, right? The 2 dots to separate example values. We can use the dash sign to separate one value from the total. We can use as a decimal after dividing one value by the total, or as a percentage after dividing one value by the total. So what does that mean? Let's start very simple with a ratio. So sometimes we will do when you're taking votes in your class, do you like pizza better or do you like hamburgers better? And you vote. You might be able to say the ratio of people that like pizza to hamburgers was 5 to 8. 5 people liked pizza, 8 people liked hamburgers. That is a ratio. You could also write, if there is a 1 boy and 3 girls, you could write the ratio as 1 to 3, right? So there are a few different ways, but let's take this question here. If there is 1 boy and 3 girls, how could you write the ratio? I'm gonna let you annotate here. Okay, so 1 to 3, right? We could write it 1 to 3. We could write it 1-3. Okay, if you were finding the decimal, what this means is you can take 1 and you can divide it by the total, right? So you can do that, or you can take 1 and divide it by 3 and you would get the percentage. So that would be, I think it's 3 should be this. Okay, 1 to 3. This would be the percentage, and then the decimal would look something like this, 0.33. All right, I just double check. Oh, did I hit record? Okay, just double checked myself. I was right, but this 3 is a repeat. So it's 0.333333 repeat, just to be mathematically accurate. Okay, let me clear my annotate. Go and go to the next one. All right. We have rate, a comparison of 2 related quantities, right? So the second quantity is usually time, and the first can be usually what they are doing in that time. So you might say miles per hour. He is driving 30 miles per hour, okay? In an hour of time, the rate would be 30 miles that person is going to drive. It can be in the style that or as a single number calculated using division. So what does that mean? It's just very simple. So you might see, here's an example. Sam makes 3 pancakes every 6 minutes. That is a rate of 3 pancakes per 6 minutes. That's simple. It's stated here. Now, if we wanted to get a minute, we would have to take 3 pancakes and divide it, right, to get the rate per minute. So this says he can make half of a pancake per minute. We know that there are 2 halves in a whole. So 2 halves equal 1. So 2 times 6 is 12. Okay, so he can make 0.5 pancakes per minute. If we wanted to find out per hour, okay, if he can make 3 pancakes every 6 minutes, if we multiply that by how many minutes are in an hour, we would be able to find out that he can make 30 pancakes per hour. And we know that his hourly rate is 30. So as long as you have how many of something in a time period, we are able to convert that many different ways. So just remember, we're usually taking 2 quantities and comparing them, what someone can do in a certain amount of time, or how far you can get in a certain amount of time. And now to just wrap up, I wanted you to do a practice. So this is a ratio/rate question. The word work problem practice is Micah can eat 21 hot dogs in 6 minutes. She wants to know how many minutes it would take her to eat 35 hot dogs if she kept up the same pace. So you know that she can eat 21 hot dogs in 6 minutes. How many minutes would it take for her to eat 35 hot dogs? So you're going to have to go back to how you calculate the rate, use some of your previous knowledge about your ratios, how many she can eat, and see if you can find out and answer my question. How many minutes would Micah need to eat those 35 hot dogs? If you get really stuck, you can go watch a video on Khan Academy and you can find out, or you can try it. And I would really love you to email me your answer, and I will be sending a surprise if you get me an answer by the end of the week to your houses for participating. All right. I hope that this was helpful, and I hope you can use it a little bit, and I hope you have a great day. Thanks for joining me on the math word problem work practice. See you later, guys.